Okay, so this is lecture number 9, and we will continue with the drainage system. We are discussing the drainage system from past two classes. In the last class, we discussed about the drainage basins of India, starting from Ganga, and we also discussed Godavari, Krishna, Kaveri, all major drainage system of India, their tributaries, right, and the projects which are going on these tributaries. Now, although the topic that we are discussing today is not particularly or per se part of the drainage system, but we will be discussing this topic in this head only. The topics, like the first topic that we are doing is the today the riverfront projects. Okay, the second topic that we will be doing is the provinces, groundwater provinces. Okay, and the third part we will be doing is about the surface water utilization in India, right? And the next part that we will be doing is the problem associated with the surface water utilization, problem associated with surface as well as groundwater utilization. Okay, so these will be the topics that we will be discussing. Okay, so let us start with the first topic, that is the riverfront projects. Okay, the first one is the riverfront development projects. So riverfront and development, this is what we are going to do first. So what is riverfront development? The riverfront development is nothing but the beautification of river, or you can say it is a reclamation of the floodplains of river, right? What you see is that in the riverfront development projects, the floodplains of river are reclaimed and they are reconstructed, and the main purpose is nothing but commercial. So in essence, if you see, by riverfront development projects, we are moving a paradigm shift actually from ecological perspective to commercial perspective. And the best example of this is the Sabarmati riverfront development project. Sabarmati wait a minute. Sabarmati riverfront development project. Sabarmati riverfront development project. Now this project was envisaged in 1997, and the work on this project was started in 2005. And what was envisaged, that the riverfront of up to length of 105 kilometer would be developed. In this riverfront project, the walls of 4 to 6 meter were constructed on the banks of river Sabarmati, and this stretch of 105 kilometer was entirely in the Ahmedabad Municipal Corporation ranges. Now, the Ahmedabad Municipal Corporation claims that by constructing this riverfront, or by doing the development project on the riverfront, they have changed the urbanization pattern in the favor urbanization pattern, in the favor of in the favor of more stabilized thing, right? So Ahmedabad Municipal Corporation claims that this project was a successful project, right? But there are many limitations which can be seen from this kind of projects, right? These riverfront projects. So there are number of problems which are associated with the riverfront development projects. So problems associated with the riverfront development projects. For example, in case of Gomati River, in case of Gomati River, the riverfront project was developed on a stretch of close to 100 and 8 kilometers, not 100, 8.1 kilometers. So this was the length of the Gomati river front, and in this front the width of the river decreased from 285 meter to 100 and 100 to 135 meters. So this is the decrease in the width of the river, the narrowing of the channel. So this narrowing of the channel, this, if you see, this narrowing of channel in case of Gomti river has influenced the floodplain ecology. Okay, what happens in case of floodplains? There is wide variety of, there is varied flora and fauna, right? So this flora and fauna is adversely affected because of the riverfront development project. You are concretizing the riverfront, you are concretizing the floodplains, you are making the walls separating the river, the narrow river channel from the floodplains. So this affects the floodplain formation and their growth, leading to impact on the flora and fauna. The next thing that is the negative about this thing, the floodplains, is the riverfront development project, is that when you concretize the floodplain, okay, then you are stopping the groundwater formation. Now this formation has a very important role in supporting the river channel, in supporting the river water in the dry season through groundwater flow, right? So in case of in the dry season, the groundwater supports the river through what is called as the groundwater flow. So when you concretize the floodplains, you are actually stopping this process of the groundwater flow. Okay, so you are ultimately turning the river into a hungry river. So you are turning river into a hungry river. Okay, the next thing is that the third point about the riverfront front development project is that their development is totally commercial centric. Okay, commercial centric. And in this commercial centric attitude, What we ignore is the ecology, local ecology plus local population. Okay, so this affects the local population adversely, which depends upon the local population, which depends upon the flora and fauna. Okay, local flora and fauna. So this is damaged, and this leads to adversely affecting these people. Second, the next point that we can also write is the about the pollution in the river pollution. See, the development of a riverfront project or so-called beautification, so-called beautification is no guarantee. This so-called beautification is no guarantee that the pollution in the river will decrease. In contrast, we have seen the increase in pollution in the river. Right? So this is also a negative effect. Right? So what we can ultimately say that these engineering methods, these engineering methods, which are also called as the hardcore methods, are not solution but problems. Okay, but problems, right? So they must be avoided at any cost. Okay, so this was the first topic of the riverfront development projects. Now we will move to the second topic, and the second one is the we will actually the topic is covered under the water resources. So you can say that we are covering the water resources here only, right? And we will mostly focus on the water resources of India, right? So first of all, the water resources of India can be divided into surface water resources, surface water resources and the groundwater resources and groundwater resources. Okay, so we will do both of them separately, surface as well as the groundwater resources, right? So let us move the first of all the groundwater. We will do first the groundwater. Okay, the groundwater resources, right? Now the groundwater, we will divide the groundwater in three provinces. Okay, in three provinces, and these three provinces are: number one, the consolidated provinces. The consolidated provinces include further the Precambrian crystalline formations, Precambrian crystalline province, Precambrian sedimentary province, okay. The next one is the Deccan Trap, and the fourth one is the Himalayan province. So this is the consolidated province. Now what are these are the part of consolidated province. The consolidated province has least groundwater because they are crystalline rock. They have the least tendency for formation of the groundwater aquifers. Plus, they have the steep slope actually. Steep slope, for example, in Himalayas. So here there is very less chance of residence of the water. So because of less residence time of the water, the formation of groundwater is minimum. Now if you see this, sorry, okay, this is the India. This part of India is the Precambrian. This one, number one, Precambrian crystalline province. So this is called the Precambrian crystalline province. Okay, this part is the Deccan Trap, third one. This is the Deccan Trap, this one. Okay, Precambrian sedimentary province. This is the Precambrian sedimentary province, the Malwa one, the Bundelkhand one, Aravalli one. This is the second one, this one, Precambrian Deccan Trap 2, this one. And this is the Himalayan part, fourth, this thing, Himalayan province. So this is the first groundwater province of India, that is the consolidated province, which include these four provinces and has the least groundwater because of the crystalline rocks. And these crystalline rocks, even though we are writing that here sedimentary, but this sedimentary is actually metamorphosed, so no water province is found in this region, right? So this all is this that we made 2 3 1 4 has least water developed, right? And we also told the reason for this thing, right? So this is the first of the three provinces, consolidated province, right? Moving on to the second, that is the semi-consolidated province, right? The semi-consolidated province, the second one is the semi-consolidated province. Semi-consolidated province also made up of the hard crystalline rocks, but slope here is moderate slope, right? So because of that moderate slope, there is the moderate groundwater potential. There is moderate groundwater potential. Okay, moderate groundwater potential. Now if you see, the semi-consolidated province has two sub-provinces that we will classify, number one and number two. The number one is the Gondwana sedimentary, that we call Gondwana sedimentary province, and the second one is the Cenozoic fault basin, right? So these two are the part of semi-consolidated province. Okay, now let us make it in the map where these two the Gondwana sediment and Cenozoic basin fall in India. Right, so this is the Narmada basin, this is the Tapi basin, and these two are this Cenozoic basin. So these two are Cenozoic basin, right? Cenozoic basin. The Gondwana sedimentary, one is in this region, this is Gondwana sedimentary, and another is in this region. So this is the Gondwana sedimentary groundwater province, this one and this one. Okay, so this is the semi-consolidated province. and we said that it has the moderate groundwater potential, and the groundwater basically has the forms through not primary permeability but through secondary permeability. So groundwater forms through secondary permeability. And what is secondary permeability? Secondary permeability is secondary permeability develops through faults and cracks, right? So this is the second province, that is semi-consolidated province, right? Moving on to the next province, the last and the third province, that is the unconsolidated province. Now unconsolidated province has the groundwater aquifers. These groundwater aquifers forms through the primary permeability, and this primary permeability is the nature of which are the rocks which are found here, and the rocks are the sedimentary rocks, for example in the Ganga basin, sedimentary rocks, right? Okay, so this unconsolidated province is further divided in two provinces. Number one is the Cenozoic sedimentary rocks, Cenozoic sedimentary province. Okay, and the second one is the Ganga Brahmaputra province. Ganga Brahmaputra basin. Okay, so both of the map can be made very easily. For the Cenozoic sedimentary, so let us make it. So this is the map of India. This is the Ganga Brahmaputra region, this region, right? So this is the Ganga Brahmaputra basin, and for Cenozoic sedimentary, one is at this point, and the second one is in this belt. Okay, so this is Cenozoic sedimentary province, this one and this one, and this is the Ganga Brahmaputra basin. So this is the third part, that is the unconsolidated province. So we did the three provinces. Okay, the consolidated crystalline province, the semi-consolidated province, and unconsolidated province. Unconsolidated province has the highest presence of groundwater because of the primary permeability, and this primary permeability is the basic character of these sedimentary rocks. And this unconsolidated province is divided in two provinces, that is, first is the Cenozoic sedimentary province and the second one is the Ganga Brahmaputra basin. So this was the topic here. Now this next topic, the connected to this groundwater development only, the issues associated with the groundwater. So it is again important. So issues associated with the groundwater. Okay, so then we will do it in two parts. Number one is the quantitative issues, okay, associated with groundwater, and second is the qualitative issues associated with groundwater. Okay, the quantitative issue, this is related with the groundwater development. Okay, and here a case study of the western northwest plains of India can be given. So of India, that is Punjab Haryana region. Punjab Haryana and western UP. Okay. Now what happened in this, because of the subsidy provisions, okay, the excess groundwater development and the tube well irrigation led to the excess extraction of the groundwater, right? So excess extraction of groundwater happened in this region. So this over exploitation can be depicted in the spatial form also, right? Here. So sorry. So what we will see is that this region, along with this region, has the over exploitation of the groundwater. So this region has over exploitation, that is more than 100% groundwater development is there. 100% groundwater development. And what do we mean by groundwater development? That is the irrigation through the tube well irrigation system. So, and when we mark with the this adjacent region of this province or this belt, this region, this region has the groundwater development between 70 to 90%, right? And the remaining India, okay, the remaining one, has the groundwater development which is less than 70%. So this is more or less a safe part of India. But these two are the exploited regions, exploited and overexploited regions of India in terms of the groundwater development. Okay, and the main reason is the green revolution and excess extraction of the groundwater using the tube well irrigation method. So this was the main reason here. Okay, so this was the what we said is the quantitative issue associated with the groundwater. The next is the qualitative issues associated with the groundwater. Now in case of qualitative issues, we are mainly concerned with the pollution. So the pollution, if you see, the river water or the groundwater is can be polluted because of the natural sources. Okay, natural sources plus anthropogenic sources. Anthropogenic sources. Now when I say the natural sources, the rocks, they may be fluoride rocks. Okay, for example, in the groundwater province, any particular area, there may be fluoride rocks. There may be the disintegration of these rocks, or there may be nitrate based rocks. Okay, there may be disintegration of these rocks also. So this leads to the excess concentration of these chemicals in the groundwater. Okay, and this happens in many parts of the Ganga basin and Brahmaputra basin. Ganga and Brahmaputra basin. For example, the concentration of fluoride in the Ganga water, particularly in the West Bengal, is very high. Particularly in West Bengal, very high. Right? And this is because of these natural factors. But natural factors are alone not responsible. The main reason is the anthropogenic factor for pollution. Anthropogenic factor. For example, the disposal of the sewage or the waste. Disposal of sewage waste. Right? This is the main reason for increasing the concentration of nitrates, fluorides, arsenic compounds, all these in the river water. Now, if you see the quantitatively, the concentration of these chemicals, For example, here I am writing the contaminants in the groundwater. Okay, and here the states affected with these contaminants, states affected. With the arsenic contaminant in the groundwater, there are 10 states which are affected. Okay, with the fluoride, there are 20 states which are affected. With the nitrate contaminant, there are 21 states which are affected. And with the iron contaminant, there are 24 states which are affected. So this is the concentration of the contaminants, you see the affected areas. So this is basically the groundwater here, the issues associated with the groundwater, and the groundwater provinces that we saw here, the unconsolidated province. Okay, then we semi-consolidated province and the consolidated province. So this is all about the groundwater development and the groundwater resources, right? Moving on to the next topic, that is about the surface water. So next we will do the surface water. Now if you generally see the surface water maybe you see through rivers, or you can classify them in canals or ponds, tanks, etc. Right, so all these parts will fall in the surface water development system. Okay, so we will study with the first of all the we can say that the concentration of surface water, right? How much surface water do we utilize, how much surface water is present, and on what factors does it depend? So we will study first of all these factors. Okay, so let us start with this thing, the surface water. So the surface water depends upon the precipitation, glacial melt, okay, your evapotranspiration, okay, and the loss, seepage loss, you can say. So all these factors affect the ground as the surface water. Now in the presence, if you see the presence of the surface water, let us make a chart for that. Now you see, in India we have the utilizable water, that is the 1123 cubic kilometer. This is the utilizable water. Okay, this is utilizable water. Okay, and in India the existing surface water storage capability, that we have the surface water storage in dams and reservoirs, ponds, etc. Surface water storage is 214 kilometer cube, right? This is the surface water storage. And the groundwater development, the groundwater presence or the development, the groundwater, that is 433 cubic kilometer, right? And the surface water in rivers, canals, etc., this is 690 kilometer cube. Now if you see, we have the utilizable water in India, that is 1123 kilometer. But if you see the actual utilization of water, that is, now let us make the separate thing that for that. In the we utilize 577 kilometer cube, this much, close to this much for the irrigation. So this is utilized for irrigation 553 kilometer cube, this much water is utilized for irrigation. In the domestic, so the domestic usage of water is 43 cubic kilometer, 43 cubic kilometer. So this is the domestic usage of water. Domestic usage of water. Okay. And if you see the industry usage of water, this is industry usage of water. This one, this is industry. And industry usage of water is 37 kilometer cube, right? And if you see the energy, the water that is used in the energy, this one, in energy part or energy generation, that is the 93 cubic kilometer. Okay, but this is the utilizable water, that is 1123. Okay, so this much water presence, this much, this space is still left unutilized. That means this, we are getting impression from here, that means that utilizable water is more than the water that we are utilizing. But this is not the actual picture. Okay, because this is just a mathematics. But if we really see, the India has the shortage of water. Now how it is shortage of water? If you see the per capita water in 2010, we had the per capita water availability 977. In 2025, the per capita water utilizability will be 806, and the by 2050 the per capita water availability would be 685. So you see, there is decreasing per capita availability of water. But from the previous diagram, we are seeing that utilizable water is 1123 and we are utilizing much less. But where is this problem? The problem, the difference actually comes because of the many factors. Number one is the surface water seepage losses, evaporation losses. Okay, and then we do not have adequate storage capability. So these all factors make the previous diagram a misleading diagram, because we can say that we have the utilizable water of 1123. Okay, but we are utilizing this much. In this, actually this is actual utilizable water. In this utilizable water, we are losing losing much water. Now losing water means we are losing water in this seepage loss, evaporation loss. Okay, we do not have adequate storage. Now in case of storage, if you see, we have currently close to 204 cubic kilometer storage capability, right, in dams, reservoirs, tanks, ponds, etc. And this storage capability can only be increased up to 400 cubic kilometer. Okay, and now why this can be increased up to this much? Because of the many constraint, whether it is the financial constraint, the constraint on availability of land, right, topographical constraint. Okay, so that's why we are saying the previous diagram is misleading, because neither we have the adequate storage capability to store this utilizable water. So this is lost either in the sea or because of evaporation, seepage losses, or getting polluted. So this 1123 cubic kilometer, that we are saying that we have this much utilizable water, the actual utilizable water, okay, this is potentially utilizable water. Okay, this is potential utilizable water, potential utilizable water, but actual utilizable water is much less. So we can say that actual utilizable water may be something here, may be present something here. Okay, making us actually a water deficient country, and we actually are a water deficient country. Okay, so this was the brief of this thing, the surface water. Okay, now if you see, now let us relate this thing, water availability, surface water availability, with the utilization. Surface water availability, Okay, so we will this this surface water availability and utilization, we will relate these two things, right? Now before doing this, let us make a diagram of India, dividing it into a set into different river basins. Okay, so that is, first of all, see, this is the, what we will do is we will divide India into the different drainage basins. So this is the Indus region. Okay, this is the west flowing river 1 region, WFR1, west flowing rivers 1. Okay, this is the Sabarmati region, this is Mahi. Okay, this is Narmada, this is Tapi region. Okay, so let us mark this is the Sabarmati zone, this is Sabarmati. Okay, this is Mahi, this is Narmada zone. Okay, this is here Tapi. Okay, and this is here west flowing rivers 2 region. Okay, and here is the Godavari region, this is Godavari, right? Here you have the Krishna, right? And this is your east flowing river 1. Okay, here you have the Pennar basin, this is Pennar. Okay, and this is the Kaveri, and here in this one is the east flowing river 2. Okay, and here you, this thing is the Mahanadi basin, Mahanadi one. And okay, this thing is Brahmani Betrini, right? This is the Ganga one. Okay, here this is the Brahmaputra. Okay, and this one is the your Meghna and Brak. Okay, so we divided this, so we will utilize this graph in this surface water utilization, availability and utilization. So when we will relate the availability of water, surface water, with the utilization in different regions, then we will utilize this graph, right? So let us do the relationship between these two, the availability and the utilization, right? So the first division that we will do here is the first part that we will do of this thing is the regions which are physically water scarce, physically water scarce and food deficit basins. Okay, so these regions are physically water scarce, but also the food deficit. For example, these regions support 6% of the population, India's population, right? But only produce 4% of grains. So these are actually the food deficit region. Now when we'll write the river basin, then you will automatically understood, yes, they are the physically water scarce also. These include, the river basin include west flowing river 1, the west flowing river 1, region number 1. Okay, Mahi region. Okay, these include the Sabarmati also. Okay, so this region is what we are talking about. So if you see in the graph, we are talking about this region here in the west flowing river, this region and this region. Okay, so we did the first part, that is the physically water scarce and the food deficit basins. Okay, the second one, that is the physically water scarce but food surplus. Now they are physically water scarce as the first ones were physically water scarce but food surplus basin. Okay, now these include the Indus basin, this is the green revolution belt, plus Pennar basin, right? Pennar basin. Now why we are called this as a food surplus? Because this region has the 27% population, India's population, plus sport the 25% or produce 25% grains. Okay, but this region has a challenge, and the challenge is the groundwater depletion plus the salinization. Okay, now this, let us mark this on the map. So what we are talking about here is the Indus basin, this region, plus the Pennar basin, where there is food surplus nature. Okay, so we did the second one, that is this thing, the food surplus and the water scarce. The third section, that is the economically water scarce and the food deficit basin. Economically water scarce and food deficit basin. Now what is meant by the economically water scarce? Economically water scarce means there is potential of groundwater development, there is potential of water development in the form of canals, tube wells, ponds, etc. Okay, but has not been developed currently. And the food deficit, if you see, this economically water scarce region include the 11 basins of India. Okay, so 11 river basins are part of this economically water scarce region. And food deficit in the sense that this region has 75% India's population but produce only 62% of the grains. So that's why we are saying that it is a food deficit basin. Now what are these 11 basins which are economically water scarce? These 11 basins include Ganga, Narmada, Tapi, Mahi, Sabarmati, Godavari, Krishna, Kaveri, west flowing river 2 and east flowing river 2. So these are these 10 rivers which are part of this water scarce. Now which are these? We have told you that these 10 rivers are these: the Ganga river, Ganga basin, Godavari, Krishna, Kaveri, EFR2 and WFR2, Narmada, Tapi, and this Mahi, and as well as the Sabarmati basin. Okay, so this is the third part, that how the utilization is related with the availability, the third division. Sorry. Okay, now the fourth division that we will do here is the the non-water scarce and food sufficient. Okay, there is no water scarcity. Now, which of these regions fall in it? This include the Brahmaputra plus the Brak River Basin, low degree of low degree of development here, both surface water as well as the groundwater development that we are talking about here. The 5% population produce 4% grain plus 6% non-grains. That's why we are saying this is the food sufficient region. Okay, so which is this region? So this part Brahmaputra and Brak region, this Brahmaputra region and Brak region here. Okay, so this is this fourth one. Moving on to the next one, that is the fifth division of between relations between the availability and the utilization. Yes, the fifth one, that is the non-water scarce, as the previous regions were non-water scarce but not food sufficient, food surplus basins. They are food surplus. Now, which are these regions? This include three basins. It has three basins. Number one is the EFR1. Number two is the Brahmani Betarni basin, and number three is the Mahanadi basin. Right, so these three basins include in it. Now, 7% population. Why we are saying food surplus? 7% population produce 8% grains plus 13% non-grains. 13% non-grains, right? So this is the thing here. This region also has the high depletion of the groundwater. High depletion of groundwater, right? So this one is the fifth region that we saw the surplus of in the food, but the scarce in the non-scarcity in the water, right? Now, if you see the map here, this is the EFR1 region, or you see this is the EFR1 that we are talking about. EFR1, this is the Mahanadi basin here, and this is the Brahmani Betarni basin, right? So let us see it once more. This is the non-water scarce and the food surplus basin, right? Brahmani Betarni, EFR1, East Flowing River 1, and the food surplus region. Okay, now we have done the general pattern of the surface water utilization and the surface water presence in India, where it is utilized. Now let us discuss the problems associated with the surface water, right? The problems associated with the surface water. Okay, so emerging water crisis that we are discussing here. Now, if you see some index according to water stress index, India is at 46th place in highest risk category country, right? And there are 11 cities which are facing water scarcity, worrying water situation. Out of the 20 cities, 11 cities are Indian cities, right? And this water stress index is prepared by Verisk Maplecroft. Okay, it is a London-based risk analytics firm. It is a London-based risk analytics firm, right? So this made this index. Okay, 46th is India's rank, and 20 out of 11 cities which are facing the high water or the worrying water conditions are Indian cities. Okay, now according to this index, now let us make some of the graph of the Indian cities which are facing which kind of the risk. Some high risk, some are the moderate risk, and some are low risk category. Okay, this is the water stress index here. Water stress index, right? This is population on this chart. This is the high risk, very high risk. This is the medium risk zone. This is low risk. In the very high risk, we have the here Delhi. You have Indore here. You have Nasik. Okay. Kanpur. Okay. Here you have Ahmedabad. In the very low risk category, the Kolkata here. Okay. And in the medium risk category, have the Mumbai here, right? Nagpur, Visakhapatnam, and Pune. This is Pune, Visakhapatnam. Okay, and this is here your Nagpur. So this is the chart of water stress index of the 11 cities of India. Okay, which are facing the extreme water scarcity or the water risk as per the water risk index report. Okay, now we must see the some of the causes of the water stress. Okay, now what are the causes of this water stress in India? Causes of water stress. Okay, there are many causes which can be written here. Number one is the fast paced urbanization. Okay, what is happening in India, that very high metropolization is happening. Metropolization. Okay, people are migrating into the million plus cities. Okay, million plus cities, and this is putting extreme pressure on the amenities of the cities. Okay, so this is the one reason of the water stress. The second reason is the concretization concretization of natural water bodies, like wetlands. Okay, for example, this is very fast paced. This is happening at very fast rate in Chennai, in Hyderabad, and these cities are facing very extreme risk in the water stress also, right? The next reason that can be seen is the seepage loss. Okay, leakages in the city water system, in city water grid. Okay, then disposal of waste in fresh water. Okay, so these all the reasons can be written here in the water stress region, right? Now the one chart, if you see what is happening in this, say this is water availability, but this water availability, because of all these reasons that we mentioned, is not going in this manner. This is actually decreasing, and our demand of the water is increasing in this manner. Okay, this was earlier, this was earlier presence of utilizable water, which started decreasing because of the foolishness that we committed. But the utilization that we are demanding is keep on increasing, is creating the crisis situation. So this is here a crisis situation. Okay, now we must see for these suggestions, or what we can do to improve the groundwater availability, sorry, to improve this situation. Okay, what can be the solution? So solutions are important if there is problem. Okay, the सबसे पहला जो solution होगा that we can propose is the storage, to increase the availability of the water, to increase the availability of water. Okay, now how to increase the availability of water? The question is that how to increase its availability. So availability को increase करने के लिए number of solutions can be proposed. Okay, number one is the restoration of the water bodies. Restoration of water bodies like lakes. Okay, then we can also suggest the sustainable man-made structures. Sustainable man-made structures. Okay, like rainwater harvesting. Okay, planting of trees. Okay, for this we can follow the agroforestry, urban forestry. So these techniques can be utilized here. Okay, so these methods can be utilized to increase the availability of water. In addition, the floodplain zoning can be done. Floodplain zoning needs to be done so that the pollution can be prevented in the rivers. Okay, rivers can be prevented from getting polluted. Okay, so this is the first solution that we can suggest here, increasing the availability of the water. The second is the correcting the consumption pattern. Correcting the consumption pattern. Now, how the consumption pattern can be corrected? What are the solutions that we can propose in this part? Okay, number one is the using the more water saving technologies. Using the more water saving technologies. Okay, so that water does not spill even out of anything, whether they are tap or tanks, right? Industrial sector it should be made mandatory for industrial sector to recycle the water, right? For this thing we can develop the recycling recycling plants at community level. Okay, so this is the second suggestion that we can give in consumption pattern correction. Okay, the third part suggestion that we can give is, or the third solution is, the structure of urbanization needs to be corrected. Structure of urbanization. In this we can suggest that the water grid system needs to be renovated. Water grid system this needs to be modernized. Okay, number one. Number two is the urban hierarchy needs to be corrected. Hierarchy, this needs to be corrected. Okay, so that the load does not fall on one city. Okay, so these are the solutions for increasing water problems that we can propose, whether it is with how the availability of water can be increased, how the consumption pattern can be corrected, and how the urbanization structure can be corrected. So this was this topic in the this was the last topic of this class. Okay, so we discussed quite a lot of topic here. Okay, so we discussed about the riverfront projects. Okay, then we discussed about the groundwater, its development and its usage. Where are the problems? See, we did the groundwater provinces in a manner which are given in the books, like consolidated, semi-consolidated, and consolidated provinces, and then we further divided them into crystalline, Cenozoic, sedimentary, etc., etc. But this can be divided in more easy fashion also. Like number one, we can also divide in the sedimentary basin or the alluvial plains. Okay, alluvial plains where there is groundwater development. Okay, then we can divide in the buffer zone. Okay, buffer zone. Okay, where there is groundwater, high groundwater. Okay, then we can also divide in the coastal region or the coastal plains. Again, the high groundwater development. Okay, then we can define in the you can say the peninsular region, low groundwater development here. So we can divide the groundwater provinces in this manner as well, but the manner that we did is the more standard method, right? Then we did the problems associated with the groundwater. Okay, after that we did the surface water, right? Surface water utilization, availability relation, the relations between relation then we did between the availability of water, availability, and the utilization. What is the relation between the availability of waters and the utilization? And finally, last one, we did the water crisis, the topic of water crisis and the solutions that can be proposed. So these are the topics that we covered in this class. Okay, so this is the water. Then we will move to next topic in the next class. Okay, so we have completed the topics associated with the water system drainage as well. The next topic that we will cover in the next class more probably will be the land resources. Okay, land resources is again an important topic. So we will cover the land resources and try to complete the land resources in the next class. So this was it in this class. Okay, so before closing the video, you please subscribe the channel, okay, and like the video. So thank you, and we will meet in the next class.